Hello. In this video, we're going to go over naming covalent bonds. Specifically, we're going to be given the name of the compound, and then we're going to write the chemical formula for that compound. So that's going to be our goal here. And we're going to do that specifically with covalent bonds. Now, the number one thing we have to remember about covalent bonds is those are the only ones that use the prefixes when we're naming things. So if you recognize a name that has prefixes, it is covalent. If you notice that two elements are non-metals, it is covalent. To remember if an element is a non-metal, we have to remember this line. This line separates our non-metals and metals. The non-metals are on the right of that line. The metals are on the left. So one more time, the non-metals are on the right. The metals are on the left. So going from there, we're just going to go straight into this, okay? So we have carbon tetrafluoride. The number one thing we have to remember is mono means one, but we only write that for the second name or the second element. The first element does not get the mono. If it's just one, we just ignore the mono and we just write the name itself. So since carbon does not have another prefix, it is just one carbon. We've noticed we read tetrafluoride and we see that tetra is four. So we look at where's fluoride, there's our fluoride, there are going to be four of them. That's it. Simple, easy. Let's do the next one. Silicon dioxide. Silicon dioxide and oxygen are both nonmetals. They both have dioxide has the prefix, so we know it's covalent. Silicon is Si, only one, because there's no other prefix in front of them, and the first one does not get mono. Next, we have dioxide, which is oxygen, but two of them according to the prefix. That's it. Perfect. Let's just keep going. So next, we have dinitrogen trisulfide. Notice for this first term, we do have a prefix. So what does that mean? Well, that means that nitrogen does have two of them this time. And then we write sulfur, trisulfide. So sulfur must have a three, di and tri. All right, cool. Next, let's go to the next one. Phosphorus mononitride. That is one heck of a name, isn't it? So phosphorus doesn't have any prefixes. So we're going to just write a B all on its own. Mononitride has the prefix of mono. So it does just have one. The second term always, always, always needs a prefix for covalent bonds. All right. Carbon disulfide. Carbon does not have a prefix, therefore it's on its own. Disulfide, di is two, sulfide is sulfur. We have two sulfurs. Easy. Next, dinitrogen trichloride. Well, once again, our first term has a prefix this time, and it's a two for nitrogen. Then we're going to write fluoride, and we write three for the tri. Remember, all of these are here. You can find all nitrogen, fluoride. They're all there. The reason we know they're covalent is they're on the right side of that line, and they contain prefixes. Okay, next, silicone tetrabromide. Silicone is on its own, so it's just one of them. And bromide, tetra, is four. So we're going to write four bromides. Carbon dioxide, this is a familiar one that we all know, but let's make sure it makes sense. Carbon is on its own, by itself, no other prefixes. Oxygen has a di in front of it, which means the two. So carbon dioxide gets us that CO2 that we are familiar with. Next one, we have nitrogen trifluoride. Nitrogen does not have a prefix, therefore it's on its own. Trifluoride means there are three fluorides. Boron trisulfide. Boron is on its own, so it's just going to be a B. And trisulfide means it's going to be three sulfurs, just like that. Last one, disulfur trioxide. our first term has a prefix. So we're going to write sulfur and two of them for the di. And then trioxide means we get three oxygens. So that is how we write names to formulas when we're doing covalent bonds. Pretty simple stuff. We just have to make sure that either they have prefixes, which gives us the hints that they're covalent. They're on the right side of our line and on our periodic table that shows the difference between metals and non-metals. And then from there, we can just put it all together and use the prefixes the name gives us to pretty much write out the entire formula. So pretty simple stuff. In another video, I will do where we're going to go from formulas to names for covalence. And yeah, if you have any other questions, want me to do a specific problem or formula, please just send me an email or mention it in the comments and I'll get to it. Other than that, I hope everyone has a great day.